All right, so today's lesson is symmetry. These are notes 9-4. So there are three different types of symmetry. Let me see if I can make this straight. All right, so there are three different types of symmetry. There's line symmetry, point symmetry, and rotational symmetry. Point and rotational symmetry are somewhat similar, so we'll talk about the differences. Line symmetry is the one you're most familiar with. So line symmetry, essentially, can you put a line through the figure diagonally, horizontally, vertically, and cut that figure into two perfectly equal halves? So you do like to think, or we like to think, in terms of the fact that line symmetry gives us a mirror image. On one half of the line, when we draw the line through the figure, versus the other half, they should be mirror images to each other. So on this figure here, there's only one line of symmetry that we can draw. And if I were to draw a line of symmetry with a straight edge, wouldn't it be right? Oh, missed it. Missed it by that much. Wouldn't it be right through here? So if I can put a line through it and cut it into two perfectly equal halves, then you can do so. Like, I cannot put a line through it this way and cut it in half. I cannot put a line through it diagonally and cut it in half, but there are some figures that we could. On this one, couldn't I put a line through here diagonally, or here diagonally? I could put a line through any of these rays of the sun, if you will, and it will create a line of symmetry on this sun. Wouldn't you all agree? Okay, so this sun itself has line symmetry. So a figure can have more than one type of symmetry. So let's move on to point symmetry. So a figure has point symmetry if the figure is mapped onto itself by rotating the figure 180 degrees. So that's your key point right there, is 180 degrees around a center point. So look at this N. We like to use a lot of letters in symmetry. The very center of the N, wouldn't that be right about here? So put a point right there. And what this is saying is, if I rotate it, it's going to freak you out. If I rotate this 180 degrees, isn't that a 180 degree rotation? Doesn't this still look like the same N we had before? That has point symmetry, and the point has to be the very center of it. It's like you stab it in the middle, with your pencil, and then you just rotate it 180 degrees. So I'm going to rotate this back. Whoa, whoa, whoa. Doesn't that freak you out? All right. Does this have line symmetry? Talk amongst yourselves. Does the letter N have line symmetry? Can you put a line through it, horizontally, vertically, diagonally, and cut it in half? I mean, some of you might think that we could do this, right? But if I folded the letter N onto that diagonal part of it, would it map onto itself? Would it fold? No, it wouldn't. So it doesn't work diagonally, nor this direction, nor vertically, nor horizontally. So the N has no line symmetry at all. But it does have point symmetry, 180 degrees. What about this one? Does this one have point symmetry? So if I put a point in the middle of the sun, and then I went to rotate it just 180 degrees, and I'm going to put a point up here just so that we know where the top is of the sun. So if I rotate that 180 degrees till that point's at the bottom, does the sun look the same? All right, so this sun is pretty awesome in the respect that the sun has all kinds of line symmetry, right? We just proved it has point symmetry. Then there's something called rotational symmetry. So although for point symmetry we rotated this N 180 degrees, rotational symmetry says the figure has rotational symmetry if the figure is mapped onto itself by rotating the figure less than 360 degrees. So if you can rotate the figure any degree less than 360 and it maps onto itself, So for instance, anybody remember this toy from when you were a kid, a little toddler? So those of you on the video, you can't see it, sorry. So like when you're a kid, you had to figure out what shape this had to go into, and then you had to rotate it to get it to go into whatever this is, right? Any of you get frustrated and just like try to force a square peg into a round hole, so to speak? Yeah, it doesn't work. So this is all about rotational symmetry. If I can rotate a figure less than 360 degrees and it pops right back onto itself, it has rotational symmetry. So let's look at the N. Does something with point symmetry also have rotational symmetry? If I can rotate this figure 180 degrees and it look like itself, doesn't it also have rotational symmetry? Something that has rotational symmetry may not have point symmetry though. So, you know, we might have to rotate it, I don't know, I'd have to find a figure that does this. You might have to rotate it 270 degrees before it maps onto itself. I don't know, we'll look at some and see if we can find it. But it is possible, but not often, that something can have rotational symmetry but not point symmetry. But usually if it has point symmetry, it also has rotational symmetry. So on this one, we're just going to rotate it a little bit. So if I rotate it this way, one click, isn't that rotated on itself again? And we could figure out the number of degrees that was. How do I figure out the number of degrees? How many rays are on the sun? 8. So couldn't I take 360 and divide it by 8? Somebody take 360 and divide it by 8. Anybody have a calculator handy? Because it doesn't go in. What is it? How many times? 45. So what that means is that we just rotated it 45 degrees, boom, it clicked onto itself. Let's do it again. Another 45 degrees. Isn't that now at 90? Another 45 degrees, clicked onto itself. Oops, another 45 degrees. Now we hit our point symmetry. Another 45, another 45, 45, and finally 45. So there's your rotational symmetry. Any questions on that? All right, so what we're going to do is look at 1 through 8. And we're going to determine, does it have line, point, rotational symmetry, or none? It's possible something has no symmetry whatsoever. So look at number 1, does it have line symmetry? All right, so draw the lines of symmetry through it. So I'm going to just draw a little diagonal here. So that's 1, isn't it? Is there more? You just have to prove it with 1. There are more. There's 1 through here, right? There's 1 through here. So there's several line symmetries. So we're going to check that. Check, check. What about point symmetry? Let's put a point in the middle. How far do I rotate it for point symmetry? 180. So if I rotate this 180 degrees, does it look the same?
Yes.
Right? So okay, so it has point symmetry. So we're going to check that. What about rotational symmetry? So I'm going to put a dot at the top. So hang on, here's the dot at the top. So if I turn it, does it look like the original now? No? See how that's harder? It is the original. If I just turn it just like that, isn't this where the top is and the bottom and I have 3 sides? So that was less than 360 degrees, wasn't it? All it takes is 1 click. And so that also has rotational symmetry. So we're going to check that. Check, check. All right, so let's move on to 2. So look at 2. Does it have line symmetry? Yes, where? So I can actually, not all triangles have line symmetry, but this one does because it appears to be an equilateral triangle, or isosceles triangles do, correct? Scalene triangles are not going to. So put your line of symmetry through there. So there's your line of symmetry, so check that. Your point symmetry, put a point in the middle, right in the center, and we're going to, and then this is our top point right here, so it'll tell us when we rotate it 180. So notice when we rotate it right now, it's got a point at the very top. If I rotate it 180 degrees, does that look the same? So it does not have point symmetry. Does it have rotational symmetry? So here we go, start it up here. If I rotate it, what, 120 degrees, doesn't that look like the original? So something can have rotational symmetry and not have point symmetry. So this one has rotational symmetry. Any questions so far? Okay. So then let's look at 3. Does 3 have line symmetry? If you think yes, put a line where you think it goes. And then fold your paper on that line and see if it maps onto itself. I can't fold this up here. If I put a line through it right here, is it going to map onto itself? A diagonal line? No. How about a horizontal line this way? Will it map onto itself? Nope. How about a diagonal line this way? Did I already do that one? Nope. How about a vertical? Nope. It doesn't have any line symmetry. I can't fold it in half and have it map onto itself, so there is no line symmetry. What about point symmetry? So we're going to put a point right in the middle, and I'm going to put a point right up top here so I can tell when I've rotated 180 degrees. So here we go. Rotate 180. Does it look the same? Yep. So it does have point symmetry. So we're going to check that. Check, check. What about rotational symmetry? If it has point symmetry, does it have rotational symmetry? Yeah, because if it has point symmetry, we rotate 180 degrees and it looked like itself. So I don't have to prove it. It's 180 degrees before it becomes rotational. But at 180 degrees, it's rotationally symmetric. Does that make sense? If it has point symmetry, it's going to have rotational symmetry. All right, look at 4. Does this have line symmetry? Can I cut it anywhere? No, not that I can see, right? So no line symmetry. What about point symmetry? So let's put a point in the middle. And we're going to put a point straight up top. And we're going to rotate this 180 degrees. Does that look the same? Definitely not. Let's keep rotating it until it looks the same. Tell me when. Tell me when. Oh, right there. So it took 360 degrees for it to map onto itself. Is it rotationally symmetrical? No. So this one has no symmetry at all. Look at 5. Does 5 have a line symmetry? Where? Is that line symmetry right there? Is there any other one? Where? You could do it this way, couldn't you? And you could do it this way, right? So it does have several points of line symmetry. I'm just going to share that one's really hard for me to see. I can only see it right side up, but we're good with it. All right, let's try point symmetry. So I'm going to put a dot in the center. I'm going to put a dot up top so I know when I've gone 180 degrees. So turn this 180 degrees. Remember, we had a point straight up top. Is that the same? Definitely not. There's no point. There's no point up here. There's supposed to be a point up top. So let's re-rotate it. So we started there. Does it have rotational symmetry? If I rotate it one click here, does that look the same? Yes. And was that less than 360? Yes. So something cannot, again, something cannot have point symmetry, but it can have rotational symmetry. So that's a check. Look at 6. 6 likes to really play havoc with me. On this weird squirrely thing, right? Does it have line symmetry? There? No, because this is going to map over here. How about here? This is going to map down here onto a blank spot, so no. What about here? Does it have line symmetry? Talk. Chit, chit, chat. I don't see where it does, do you? Okay, it doesn't. What about point? No, we already have a point in the middle, right? So what about point symmetry? I'm going to put a point right up top. Please note that this squirrely thing is on the right, and this squirrely thing is on the left, and this is squirreling to the left. Agreed? And this is squirreling to the left. So when we rotate it 180 degrees, we have a squirrely thing up here and a squirrely thing here. Isn't that what we had before? This is squirreling to the left. This is squirreling to the left. Is it the same? All right, I'm going to agree with you. It's the same. So it has point symmetry. Yep. So if it has point symmetry, it also has rotational symmetry. 180 degrees rotational symmetry. 7. Now we get another letter. Love the letters of the alphabet. My favorite, as I said the other day, is S. S is really hard to rotate, just saying. All right, so look at A. You draw in if there is any lines of symmetry. What do you think? None? If you cut right down the middle, so then there is one, right? You can cut right down the middle. So if I cut right down the middle, there is a line of symmetry. Agreed? If it cuts it in 2 perfect, beautiful halves, and you could fold it right there, and it maps onto itself, that's line symmetry. So let's test point symmetry. So I'm going to put a point right in the center, put a point right above so I know where 180 is. What do you think is going to happen? If I rotate it, my A is going to be upside down, isn't it? So it doesn't have that. If I keep rotating it, will A ever map onto itself before 360? No. So all it has is line symmetry. Okay, so let's move over to 8. You do by yourself, see if it has line, point, or rotational symmetry. Fun little lightning bolt. I just love quirky figures. All right, so chat amongst yourselves about what you think. Does it have line symmetry? Does it have point symmetry? Does it have rotational symmetry? Okay, Emily, what do you think about line symmetry? Was anybody able to draw a line through this and cut it in half? So this doesn't work through here? No, this bottom part messes it up, right? Well, actually, a lot of it messes it up, doesn't it? All right, so it doesn't have any line symmetry. Point symmetry. Jordan, what do you think about point symmetry? What would you say? No, so if I put a point in the middle of the figure and turn it 180 degrees, the lightning bolt's now going up and to the left, correct? And if I keep rotating it, whoops, does it ever map onto itself? Not until 360, right? So what was your conclusion? There is none. All right, so then I want you to turn to, and you're going to find your table group members, and you're going to go through 9 through 20, and you're going to determine 9 through 20 what its symmetry is. So I'm going to give you, about 5 or 10 minutes, and I'll pause the video. So here's the answers to 9 through 16. How did we do? Any questions on 9 through 16 that we want to talk about? Notice that any time it has point symmetry, it also has rotational symmetry, but not vice versa. It can have rotational symmetry, but without the point symmetry. And number 13 is a perfect example of that. Yes?
What about 16? Why is it also
What about 16? What's your question on it?
like that right down
But the design, the design of the queen, the design of the queen is what messes it up for line symmetry. Does that make sense? If I cut it right here, the design does not map onto itself, so that's a good point. The outside of it has line symmetry, but because of the picture that's in there, it affects the line symmetry.
Couldn't you cut it straight across the logo like that? 'Cause then
If you
the-
cut it straight across in the
no.
middle, right here, the heads don't line up. Yeah, the heads, yeah. And the hearts, yeah. So that one's a harder one to see, right? All right, so any other questions on 9 through 16 while we're here? How well did you do on those?
I just messed up.
Just on that one? Okay. So then let's look at, the rest of them. So there's 17 through 20. How did you do on those? You like the recycle symbol in there?
I messed up on
On the recycle symbol? What did you say it had? So watch it for that line symmetry on number, are you talking about 19? Yeah. So watch it for line symmetry because, did you put a line through here?
Yeah.
The arrows don't line up.
Yeah.
Yeah. And then if you rotate it 180 degrees, this ends up on the bottom, doesn't it? So it doesn't rotate 180. And then if you try to rotate it rotationally, it does. So here, now it looks like the original, and that's 120 degrees. So any questions on that? We good? Are we good?